Building your first AI agent is simpler than you think. In part 1, we built the brain of our 2D agent. That helped us to interact with AI from the ease of our terminal itself. Now in this part, we will take it a step ahead and integrate it with a simple web UI. To enable this real-time communication, we will be using WebSockets. And to make our UI to work as an assistant, we use Claude AI to update our front-end code. By the end of this video, you will have an AI agent you can talk to right in your browser. So do watch the video till the end, and if you get to learn anything new from this, please hit the like button. Also let me know what you learned in the comments. As we can see, Terminal is powerful for building and testing our agent. But imagine we want to ship this agent to real users. A terminal app is not good enough. But a web UI provides an easy way for the users to interact with the AI. But for that real-time fluid chat experience, standard simple web requests are not good enough. That's where WebSockets come in. With WebSockets, we can maintain the user session, keep the context about the previous prompts, and use them to get accurate AI responses. Now, let's implement our WebSocket in the backend. Here we are using the fast API's built-in WebSockets feature. You see the difference in the annotation, right? For simple REST APIs, we use app.get or app.post annotation. And for WebSockets, we need to use the app.websocket annotation. Let's look at the connection manager class, because this has the core functionality of managing the connections and sessions also. So in the init method of this class, we are initializing a dictionary of active connections. This basically maintains the connections using the session ID as the key. This session ID will be sent from the front end, so you will be able to understand it better when we are integrating this with the UI. And in the connect method, we are taking the WebSocket instance and the session ID as inputs. So WebSocket.accept here waits for the WebSocket connection to be requested from the front end and accepts it from the backend. Then we are populating the active connections using the session ID and storing the WebSocket object in it. And next, the disconnect method just removes the session from the active connections object. Let's leave the agent state logic for some time. You will understand it better once we understand how this will be used in the AI agent. And the crucial part of WebSockets is the send message method. It checks for the active session, and if session is found, then it sends a message to the front end. How is it sending? Here we are just fetching the WebSocket object from the active connections using the session ID. And we are calling the send text method of that particular WebSocket object, which sends the response to the UI. And coming back to the main WebSocket function, first thing we are doing is to connect to this manager, which takes the WebSocket connection and adds the session ID to the connection pool. Now, this is the most important part of the WebSockets implementation. This while true makes sure that we are receiving the message from the UI continuously without ending the session. And then await WebSocket.receiveText waits for the front end to send a message. Once it receives the message, it lets the execution move to the next step. Then from message data, we are fetching the user message, which is the prompt for the AI agent, and the user token, which is the API token that we will be using in the tools. And then this logic throws an error if the user token is not provided, because we need it to trigger our backend APIs. Now this is the place where we are managing the agent state. We are persisting the state over multiple requests inside a single session. That means the user can send multiple messages inside the same session. All those messages will be part of this state. Remember, in the disconnect method of connection manager, we saw that we are deleting the state for a session. That means we are erasing the state as we will not use it for that session anymore. If we get a new session, this creates a new empty agent state object. So this is what makes sure that we can have multiple sessions running in parallel. That means multiple users can use our application and send multiple sessions, and each user will be having their own session ID and their own agent state. Then we are appending the user prompt as a human message to the agent state here. And this is the first place where we are sending a message back to the front end, saying that the AI is thinking. So the UI can use this to display some waiting message or loading screen or whatever. Then we are creating another object called config, which stores the user token. So this config can be accessed inside the tools. Actually, the agent state that we are populating earlier, that is not accessible inside the tools very easily. So that's why we use this config. Here we are using another powerful feature of LangGraph called the graph.aStream. This method sends the output of the LangGraph nodes in multiple chunks instead of a single output. So in the earlier code we had, it just used to send the entire output in one single response. But in here, we can actually get output for each node that the LangGraph is triggering. This can actually be helpful for us to show what steps the agent is taking in the background. Then we are passing the agent state and the config to the LangGraph here. So finally, if we get the agent or tools chunk from the graph, we are sending a message to the UI with the response. And if we get any other chunk like the input handler or the final response nodes, we actually ignore them. Then we have some exception handling to close the WebSocket connections gracefully. Now let's look at how our tools needs to be changed. For example, let's take the add to do tool. Here we just added a simple logic. We are just accepting the config as a param and we are just fetching the user token from it. So that is the only change that we are doing to the tool. And tool uses this token instead of the hard-coded one that we used to use earlier. So we can just replicate all these steps for the other tools as well. Okay, so now we are done with all the code changes in the backend. But for this code to work, we need to install some additional packages. So there is one package called WebSockets that we need to install using pip install WebSockets. If you are actually fetching this code from GitHub link, which is in the description, you should have all these dependencies in the requirements file. So you can just run pip install -r requirements.txt. That should actually install all your requirements from the previous video and this video as well. So that's it for the backend changes. Let's move on to updating our front end now. So this is what we created earlier for our to-do management UI. I think it would look great if we can use this and integrate our AI agent into this. But we don't have to write any front-end code here. We can actually use AI to make front-end changes for us using a simple prompt. Let's see how we can do that. Let's get into Claude now. This is the initial prompt I used. Let's break it down and understand a little bit more. Firstly, I attached a couple of files along with the prompt. The backend file which we just created and the existing front-end file where we need to make the updates for the UI changes. So at the beginning of the prompt, I'm explaining the attached files and what we have already. Then I'm listing our requirements here. Firstly, for backend I'm mentioning that it doesn't need to make any changes. We are just attaching it for giving it the context about the existing setup so that it will understand how the backend is set up and accordingly it will make the changes for the UI. But for the front end, we are sending a list of instructions. Now let me show the final result in parallel to give you more understanding of how AI has generated the code. Now in these steps, we are asking it to create a modern looking floating chart bubble on the bottom right. So you can see that on the bottom right, it created a chart bubble. And on clicking this bubble, it needs to open up the chart window. When the user sends the first message, it needs to fetch the user token from the local storage and create a new unique session ID and start the WebSocket session. So this is the entire logic of WebSockets that we are asking the AI to generate for us. Then I am mentioning that the UI should be modern and responsive. So this is one single line which is actually making our UI a lot better. You can actually try removing this in your prompt or explicitly asking it to provide a legacy UI. And you can let me know how you got your output in the comments. It will be actually a really fun activity. Then we are asking to create a loading feature or some way to let the user know that the AI is working in the background. Then another crucial part when we are using the free version of Claude AI is we are asking to suggest the updates only. Without this, it actually starts rewriting the entire content of the attached file, which will consume the complete limits of your free version of Claude AI. Finally, we are stressing on a couple of things again to not suggest any changes to the Python file and to not create the entire file for the front end. So once you send this prompt, it will send a response similar to this. Okay, let's go through the response now. So in the first step, it gave us the basic HTML changes required for the chart bubble. We need to place this inside the to-do app div in our existing HTML file. Then we have the CSS styles. These styles will be most probably be matching our existing styles because we attach the front-end file as well to the AI, right? Then the crucial JavaScript functions which handle the requests and show the response dynamically. Cool. Let's integrate all these changes in our existing code. But please remember, AI might not generate the most optimal error-free code in the first attempt. We might have to iterate multiple times. Not might actually, we will have to iterate multiple times to get to the best solution. In my case itself, I had to go back to the AI 3 to 4 times with the different kinds of errors that I was getting with the changes that they had suggested. Finally, after that, I was able to get to the working UI. So this is the final version of our UI. You can see that we got the AI bubble on the bottom right. If you click on that bubble, it opens up a chart window, which we can use for interacting with our AI agent. So before we start testing our changes in the UI, let's start the backend first. So we can start our to-do APIs using the uvcon main app reload command. If you don't have these APIs already, I would highly recommend you to go through my previous video, because in that video we used AI to quickly create these APIs from scratch. You can find the link in the cards or in the description. So let's start our backend agent as well by just running this Python file in the virtual environment. Great, our backends are now up and running. Let's open our AI assistant window and try to say hi. There we go. You can see that we are getting a message like AI is thinking. This is how we configured it in the backend, right? Then we get the actual response from the AI. Now let's ask what it can do for us. Cool. It says that it can manage the to-do items. Let's try to create a new to-do item with it. And that's it. It creates the to-do item for us. Looks like it is working pretty well. Wait. But we are not able to see it in the UI. I think we just need to refresh the page. Okay, here is the newly created to-do item. But do you think this is a good user experience? No, right? So let me know how you can improve this behavior in the comment section. So in this video, we saw how we can create a working backend for the WebSocket connections and how we can integrate our AI agent with the WebSockets. Then we saw how we can add AI components to our UI code using the AI code generation. In future videos, we will be building more complex AI agents and applications, and we will learn a lot along the way. If you like this video, please hit the like button. If you have any queries, content ideas, or just want to say hi, do comment below. Subscribe to the channel and hit the bell icon so that you will not miss the awesome AI content coming in the future.